So good morning everyone. So today we'll start one topic. In the last class you found out the center of gravity, right? But we didn't find out the moment of inertia. The question it was given, you have to find out moment of inertia. Now let me give you a brief introduction on moment of inertia first. Then only you can start it, right? So we'll start the topic moment of inertia today. Okay. So is it okay for everyone?
Yes, sir.
Okay. So can you tell me what was centroid and center of gravity? Students, can you tell me what is centroid of or center of gravity? Centroid or center of gravity?
Centroid means arithmetic mean position.
So in the
Short
last
form.
last class we discussed regarding what area moment of inertia, right? There's parallel axis and perpendicular axis theorem we have discussed. So today let me give you a brief introduction about moment of inertia. Okay, can you see my screen?
So,
Can you see the screen?
yes, sir.
Yes, sir. Yes, sir.
So in the last class we discussed the first moment and second moment of the area, right? So that in the last class someone else asked me also why you are taking only uh, second moment, not first moment, right? So basically that second moment is only known as the moment of inertia. Okay. So basically that second moment is only known as what? Moment of inertia. That means multiplying the area with the moment. Okay. So now here also, like the previous ones, here also you'll have to what? Remember certain formulas for the moment of inertia. Okay. That means what? First of all, to find out the moment, what we are multiplying is force about a point or area. Then we are multiplying it about a particular point, and then we are multiplying it again. So that is known as second moment of area or moment of inertia. Now, how will you consider the moment of inertia of a plane area? So in that class, in the last class, we discussed regarding this one. No? We found out in the x square it is integration of x square dA, and in the y direction it is y square dA. Now here from that only we will get the
It's blank.
what? It's blank. It's coming now. Is it blank?
Blank.
Blank.
No. Yes.
Temadar, you're not seeing anything?
Yes. Blank, sir. It's blank.
नहीं आ रहा है कुछ रुको मैं तो शेयर कर रहा हूँ आई एम
Can't
शेयरिंग बट
see any slide.
you cannot see anything. what
No,
about
sir.
oth-
It's
what
blank.
about others?
We can see.
Wait,
Can see.
let me share it again.
Can
Let
see.
me share it. Now yeah, now are you seeing? Are you able to see now?
Yeah.
Hello, students. Can you hear me?
Yes, sir.
Now audio is clear.
Yes, sir.
Yes,
Okay.
it's clear.
Okay. Okay. Wait. Let me see again. Now, are you able to see? Now, are you able to see?
Yes, sir.
Okay. Someone is saying something. So, what is mass moment of inertia now? A moment of inertia of a plane area. Okay. So, it is given by this formula: I equal to a1 r1 square plus a2 r2 square plus a3 r3 square. That means what? Say summation of all the r. Now, what is a? Now, before we used to find out that centroid, na? So, how we found out the area? That same thing only. You have to find out the area here also. And for r, for r, it is the corresponding distances of the elements from the line about which the moment of inertia is required to be found out. So, this is the distance of the elements. That means what? That same thing only. Like if you're finding, you have to find out that y1 y2 that one, na? So same thing only here also, just you'll have to find out the corresponding distance. Now what is unit of moment of inertia? It is in meter to the power 4 if the area is in meter square, and if the area is in millimeter square, then it is millimeter to the power 4. Now we'll have to find out how to find out methods of of inertia. First of all is Routh's rule, and second is integration. Okay, we will discuss basically what Routh's rule only. Now remember, look one thing now. The Routh's rule states that if a body is symmetrical about three mutually perpendicular axes, then the moment of inertia about any one of which through its center of gravity is given by a into s by 3 for square or rectangular lamina, or circular or elliptical a into s by 4. And for this one I a into s by 5 for spherical. Now this method is rarely used. Okay, so we'll be going for integration for finding out the moment of inertia. Now if you see for this method of integration, how is to find out now? So First of all, we'll do what? Suppose this shaded orange color part. Hmm. Thank you, Mannar. Mannar, you are not able to see me? Are you able to see the lectures? Someone give a message in the chat box. Okay, so how will you find out moment of inertia? By integration. Now look, for finding out the integration means what? You have to consider this one. This is a small what? This is a small body for which you have to find out what? The moment of inertia. Okay. This body is at a distance of x from x-axis and y from this axis. Now these are the perpendicular distances. Now what happens? Now suppose we have to divide the area into a large number of strips. Strips means what? Small parts. Huh. Once we divide the area into a large number of parts, then what will happen? We will what will happen? Now, if you divide this area into a large number of strips, then it will happen. If you add all these strips, then you will get. If you add the small area of those small strips, huh, you will get what? You will get the whole area. Yes or no? Now, suppose this small strip, this green color, this is of dA. Now, if you add all the dAs present here in this figure, then you will get A. Yes or no? Now let x be the distance of center of gravity of the strip on the x-axis. That's what I say. And y distance of center of gravity of the strip on y-axis. Now moment of inertia of the strip about y-axis. We discussed it in the last class. Huh? So how we found out? It is found out by dA into x square. That means what? Moment of inertia Iyy. That means about y. X axis Iyy. Huh? So we will write it as dA into x square. Now dA into x square is for that small part, right? For this part. Now if you find for this all the parts, then what happens? You just summation of dA into x square. Huh? So similarly, Ix equal to summation of dA into what? Y square. So in this way, we'll be finding out the moment of inertia. Okay, is it clear now? In the last class, we will also discuss about it. Now, how to find out for the rectangular section? Hmm. Now, if you have to find out for the rectangular section, the width is what? B, and the depth is what? D. Hmm. So, area of the strip is what? B into D. Now, look, we'll consider a small strip again. This one. This green color is a small strip. Hmm. Now, this small strip have a thickness of dy. Hmm. This small strip have a thickness of dy, which is parallel to x-axis. Okay. The strip is parallel to x-axis and has a thickness of dy at a distance of y from it. Like this is at a distance of y. That means what? From the this central axis, hmm, this is at a distance of what? Y. Okay. So if it is at a distance of y from the central axis, then area will be what? The small part is what? The small part is dy. Right. The small part is dy. Now if this small part is dy, then and the width is what, b. So area is length into b. So b into dy. So that is why we got this area. Okay. Uh, Now moment of the inertia of the strip. So moment of the area inertia of the strip will be what? Area. Area is fine. Now this is at a distance of what? This is at a distance of this, no? Y. So area into y square. Hmm? That is why we find out area moment of inertia double, two times we found out. So that is way we get what, b into dy into y square. So we get by square into dy. So this is why we get the moment of inertia of the strip about x-axis. By square dy. Now the moment of inertia for the whole section. Now the moment of inertia for the whole section may be found out by integrating. You know integration, this one. So integration by square dy. So the limit is what? Minus d by 2 and here plus d by 2. Now why you may ask me why we got minus d by 2 and plus d by 2. Okay. So why we got minus d by 2 and plus d by 2? The reason behind it is the reason that is behind it is, look, this is d, right? Now this is the neutral point. This is the neutral point. So below it will be what? Negative, right? That means what? Even if even if this is d by 2, we'll have to write it as what? Minus d by 2. And here it is d by 2, so we'll write it as what? Just d by 2. Okay, as simple as that. Now this is what the limit is all about. Okay, so this is what the limit is all about. So now once you integrate, you found out what? You are integrating like this, right? Dy I, so we are finding out for what? I xx. So I xx is what? Bd cube by 12, and Iyy is the reverse of it, db cube by 12. Now for finding out Iyy, what you'll have to do is, we found out Ixs by considering, the axis in this direction. For Iyy, you'll have to consider a strip in this direction and then eventually do all the calculations. So in this way, you will do it like this. Now you can try out this numerical. So remember, this is the main. These two formulas are main, Ixx, Iyy for a rectangular section. Okay, derivation, fine, it's okay. But derivation, apart from derivation, the most important thing is what? Is to find out, you have to remember the expressions for Ixx and Iyy. So it is moment of inertia. Is it clear for everyone? Is it clear for everyone, students? बोलो टेमल.
Sir, it's yeah.
Okay, good. So whatever others, like, okay, fine, I agree with Tema that he is clear. Okay, fine, he is interactive. But what about others? No one is giving any response in the class. Why? There are like around 53 people now. So if 50 people are present, someone should give the response, right? Okay, Meishuba is given. Clear, sir. You should give at least some responses. Then it feels good also, na? So this is how you will find out the moment of inertia. About okay, Trubajoti and all. Okay, fine. Thank you. Okay, so this is how you will find out. So remember these formulas. So let us do one thing. Let us take this question. Let me hide this answer. And can you see something
Nothing.
now? Now?
Yes, no.
So can you do this? I guess you can see it clearly, the text.
Yes, sir.
Can you do the numerical?
Sir.
Hmm. Try doing it out. Try solving the numerical. This is simple. So how will you find out? Just put in the formula just now we discussed, no? So have you done the question? Someone got the answers. Good, good. Wait, let me see who's giving the answer. Okay, good. So this is the answer. Can you see the screen? Can you see the solved numerical? Students, can you see the solved numerical?
Yes, sir.
Yes, you can see.
Yes.
Hmm. So we'll go to the next one now. So moment of inertia of a hollow rectangular section. Okay. So how to find out the moment of inertia of a hollow rectangular section? Now, if you see for a rectangular section, we found out that we discussed that the depth is d, right? So if the depth is d, so what happens is that the breadth is b, right? So if the depth is d and the breadth is b, we got it for bd cube by 12, right? Now bd cube by 12 is for the whole area. Now bd cube by 12 will be for the whole area. Now for finding out only this purple color part, for finding out only this purple color part, what you have to do is you have to remove this part, no? That means what, you have to find out the moment of inertia of this part and remove it. So it is d1 and b1, the depth and breadth. So you just simply minus it like this. So you will be getting it for the whole section. Okay. This is very important. Now, so you can find out the moment of inertia if it is given in this manner, right? Or do you want to try the numerical of this hollow section also? Students, do you want to do a numerical again for a hollow section? Do you want to try how to solve it?
Yes, sir.
You want to try? Okay, then try it. I'm showing you the numerical. This is the numerical. Just write up. And these are the formulas. This one and this one is the formula. Just try it out. Try solving it. And while doing the numericals, if you are doing in copy, then just draw the diagram also. Okay, then you will get more marks in copy. Like diagram means it will show how you are solving it, right? So for diagram also there are marks. Better draw the diagrams. Hmm. So are you able to distinguish which is the internal dimension and which is the external dimensions? Okay, very good. You are solving it. Nishita, Janvi, Idam, Imsong, very good. Just remember one thing, do not forget to put the units. Like you put the units here, everywhere while solving these numericals, you have to put the units. Okay, the answer is correct. Very good. The answer is correct. Okay, so in this way you will be solving it. Hmm. Now, what you have to do is today, just let us see the perpendicular axis theorem now. So what is actually the perpendicular axis theorem? So the perpendicular axis theorem in the last class also we discussed it in this video, my class notes. parallel axis and perpendicular axis. So there are two theorems. Now perpendicular axis theorem means what? If I-axis and I-y-y be the moment of inertia of a plane section about two perpendicular axes meeting at O, the moment of inertia of IZ, that means about ZZ axis, is perpendicular to the plane and passing through the intersection of XX and YY, and it is given by simple. You add the moment of inertia of IXX and IYY, you find out what the Z. Okay, this is how you find out. Now I equal to what? Area into distance into whole square. So this is what this is called perpendicular axis theorem. That's simple. If you add Ixx plus Iyy, then you get Izz, and this is what you have to find out, or this is how you are finding it out. Okay. So now for finding out moment of inertia of a circular section, beforehand we discussed what moment of inertia of a rectangular section. So for rectangular it was B Ixx was BD cube by 12. Now that similar thing only we will be finding out for what? A circular section. So how will you find out for a circular section? Now that similarly in that part we considered one small strip of area. Na? So here also we will be considering a small strip. Hmm. Now look, consider an elementary ring of radius x and thickness dx. Now this is an elementary ring, this purple color. Okay, so this is having a radius of what? X and thickness of dx. That means that the thickness of the ring is dx and it has a radius of this x. Okay, so if it is having a radius of x and thickness dx, then area of the ring is dA equal to what? 2 pi into x dx. Remember this. Huh? Okay, so area of the ring is what? 2 pi into x dx. How? Now dx is the thickness and 2 pi x is what? Radius. So why we know twice pi r. From this expression we are getting 2 pi into x. Huh? And dx is what? Thickness. That means what? We are multiplying by one dimension, circumference into thickness. So we are getting this area. Now the moment of area about the ring. So moment of area, how you find out? This part we got dA. dA means area for the area. dA. Now x square. Distance is what? X. No? Distance is x. So distance is x square. Huh? So we can reorganize this like this: 2 pi x cube. So here is one x. Here is one x. So 2 pi x cube dx. Now if you integrate, so if you integrate, you will be finding out this one: pi by 32 d2 by 4. Now this will be what? This will be for the whole Izz. Hmm. Now if you have to find out Ixx and Iyy, how will you find out? First of all, you found out how Izz. Izz, why? Because you are finding it for the whole circle, and a circle does not have an x or y axis. Huh. So if you are finding out for the whole circle, then you are finding out Ixx plus Iyy. And for the individual part, you will be finding out what? Ixx and Iyy. So in this way, you will be finding out, and then you will get this answer: pi dt bar 4 by 64.